Hello everyone, this is what I have for you guys today. A cone is to a cylinder as a pyramid is to a rectangular prism. But before, well, I should say a square pyramid is to a rectangular prism. And before we start talking about this comparison, let's go over what actually a cylinder is and how to find the surface area and the volume. So first we have our cylinder here, and our cylinder looks like this. And you'll see that it looks, in some parts it looks a lot like a prism. And that's because it has a base, a circular base, but still a base. The reason why it is not a prism is because it's actually curved. So, but the same idea behind finding the volume is, it's still there. To find the volume, we find the area of the base, and the area of the base, in this case, using the radius, is pi r squared, not 2 pi r squared. Is pi r squared. And the height of this, we'll just define this as h. Well, the height is the height, so the volume is equal to pi r squared times h. So you have the base, this right here, the circle, and then you kind of push it down, so you multiply it by h. So you get pi r squared times h. And so the surface area is actually a little bit more interesting. The surface area, if you imagine unraveling this cylinder, you would get a circle that looks like this. Actually, 2 circles for the 2 bases. And you would also unravel this rectangle that wraps around the cylinder. And so the rectangle will look like this. Let's talk about the dimensions of the rectangle. Well, we know that one dimension is h. This will be this over here. But what is this dimension? And what is this dimension right here? This dimension that wraps around the circle. Well, as it turns out, this dimension is the circumference of the circle, which is 2 pi r. And so our surface area for this circle is equal to pi r squared, 2 pi r squared, plus 2 pi r times h. And you can, of course, simplify this into, it seems like they didn't simplify this here. Out of curiosity, I was checking. But you can simplify this into 2 pi r times r plus h. 2 pi r squared, 2 pi r h, yeah. Actually, it's probably a good thing that, the standard is not to simplify it. Because even after simplifying this, you lose the intuition behind the actual formula. So I would actually keep it like this. But again, you do not need to remember this formula if you understand how we got to this formula. I certainly don't memorize it, although it could benefit me too. So this is the surface area and the volume of a cylinder. And the reason why cylinders are related to cones is because the interesting thing about cones is that if you have a cone with a base that is congruent to the base of this cylinder, and it's the same height as the cylinder, so your cylinder looks like this. This base, these 2 bases are congruent, so this is the same as this. And it's of equal height as this cylinder. The volume of this cone is actually equal to 1/3 the volume of the cylinder. So, using the formula, that would be 1/3 times pi r squared times h, like this. And I'm probably out of the frame. So this is our volume formula. It's 1/3, exactly 1/3, by the way. That's pretty interesting. I wish I could derive it for you guys, but alas, we do not have enough time. The surface area to get the surface area of this cone is rather complicated, actually. But alright, so let's say that you have this cone and you have the circle right here. So this is the same. The area of the circle is the same. It's always going to be pi r squared. But you also can unwrap this right here. You can unwrap this kind of, well, I'm not sure what kind of shape to describe it as, but when you unwrap it, you get something that looks like this. Maybe I can draw this better. You get something that looks like this. And there are a few things that you know about this one. Well, the first thing is it looks an awful lot like a sector of a bigger circle, right? So by sector of a bigger circle, I mean that you draw this smaller, you draw it more like this. It looks like you can extend this out so that this is in the middle of the circle, and you cover it like this. This is a very bad circle by me. Okay. This is perhaps a better circle. You draw it so it looks like this. Let's say that this is center O. And we know what this portion here is, right? We know that this is equal to this right over here. So what this is this is the circumference of the base circle, which is equal to 2 pi r. So this here is 2 pi r. And one of the last things that we need to know, or we need to figure out, is the slant. So the slant would be here. And the slant of this, I'll just call this L. The slant of this, you'll actually need to use the Pythagorean theorem if they don't give you the slant right away. And the way you'll do this is, I should get another marker. The way you'll get the slant, if it is not provided, is you have to use the height of it and the radius of the circle. So you would have to take this height right here, which is equal to h still, and you'll have to take the radius of this. So this is r, which we use down here to find the area of the circle. You have h and r, you'll see that this makes a right triangle, and so you can use that to say, oh, h squared plus r squared is equal to l squared. You figure that to figure out what L is. And L is our slant height, and it's relevant here because in our bigger circle over here, L is the radius. So let's say we put L here. L is the radius. And in order to figure out the area of this sector right here, you have to first figure out, using a bit of proportions, you have to figure out 2 pi r, which is this circumference, compared to this bigger circumference. And this bigger circumference is equal to 2 pi L. And I hope you guys are following along. 2 pi r, which is the sector length, the length, our little, corner out of this huge circumference. This is the length for our sector right here, 2 pi r. And we know that because it is the circumference of this circle over here. That in the bigger circle, the circumference is 2 pi L, using L as the radius for the bigger circle. And then we have to figure out the area of this bigger circle. And the area of this bigger circle is 2, why am I saying 2? Not 2, pi r squared. But instead of r, we use L, because L is our r. L is our radius. So it's pi L squared. So you have this area right here, and we only want a fraction of this area. We only want this fraction of this area. So we multiply it, and what we get is that, these parts cancel out, this part cancel out, this part leaves only one L. So in the end, you get L pi r. L pi r. And our surface area would then be, pi r squared plus the area of this, which is equal to slant times pi times r. And I think this is, this is the correct one. Of course, we can, instead of using slant or L, we can actually just use the height and the radius just to, minimize the number of variables. then you would get pi r squared plus square root of h squared plus r squared times pi times r. I would say, I would say that this might actually be a formula worth remembering. Maybe not necessarily for, actually probably for competitions as well, because it took an awful lot of time to derive all of this right here. So surface area of a cone might be worth memorizing. At least this part. At least this part over here, where we figured out the sector of a larger circle. Actually, let me erase this. Right here, surface area. And kind of the reason why I said that a cone is to a cylinder as a square pyramid is to a rectangular prism, is because this kind of logic, for the volume at least, also applies to rectangular square pyramids. So I'm going to erase this part, but I'll leave the formulas on the board. I'll erase this part. Whoa. Okay. The reason why I say this is because for a square pyramid, our volume works the same way. So if I draw like a square pyramid that looks kind of like, okay, this is not what I intended to do. Okay, this is our square pyramid. Okay, this is our square pyramid, and let's say that it has S right here, and the height is H. Well, the same concept applies if we had actually had just a rectangular prism. So we would have the square right here, and the square is right here. I need an art tutorial on how to draw rectangular prisms. The thing is, I drew this in an unfavorable angle. Okay, sorry, one last attempt for me to draw a decent looking rectangular prism. Okay, this is the best you're getting out of me. Anyways, let's say that if the square is on the bottom, this is S, this is also H. If all these dimensions are still the same, then the volume of this square pyramid is exactly 1/3 of the volume of this rectangular prism, and this rectangular prism is S squared times H. So our volume for the square pyramid would equal 1/3 S squared times H. And of course, you could also figure out the surface area of this square pyramid by applying the same logic that we had before to prisms, which is just drawing out the net. But I have to say, there's a fair warning. If you only have the height here, and I'm gonna like draw this height inside this square pyramid. If you only have the height here, you don't know what this is, right? So well, I'm going to draw the net for this, but the net for this looks like this. And you know what this is. This is equal to S squared. But the issue is, you can't figure out what this height here is using the height. So these triangles are not equal to S times H divided by 2. Just like, you actually have to use the Pythagorean theorem again. So if you have a Pythagorean theorem that looks like this is equal to h. This is equal to 1/2 of s. So 1/2 s. You have to figure out what this slant is over here. And this slant right here is equal to the height of the actual triangle. So this slant would be h squared plus 1/2 s. So s divided by 2 squared, square root of that. This would be equal to the slant. And then, of course, you would have to multiply that by s. You have to multiply that by s, divide by 2 to find the area of one of them, multiply by 4 because there's 4 of these triangles. And so you can work these out. And in the end, your formula for this problem, I lost my blue marker. I'll draw in purple. Your formula for this would be, let me make sure I have this correctly. It would be s squared for this square over here plus s times, actually I'm not quite sure, they must have simplified this a lot. Actually, let me make sure I simplify this. It's 2, so you would get 2s h squared plus s times s is s squared divided by 4. You would get this, and then you would also have to add the s squared right here. And then you can simplify this by getting out the s of s plus. Oh, they multiplied. Okay, I understand. This is your formula technically, and this formula works, by the way. But in a lot of cases, and notably in cheat sheets like this, they simplify it so that you just have s squared plus, and so the 2 becomes square root of 4. And it becomes square root of 4 because it's useful in situations like this, where you can multiply it inside. So 4 times h is 4h squared plus s squared. And so this is your surface area formula. I highly do not recommend memorizing this surface area formula, mostly because you do not need it. If you understand how we get this slant over here, and you plug in all the numbers, you don't have to do simplifications like this. You can just plug in the numbers. Alright, and so this concludes the reason why I wrote in the beginning, a cone is to a cylinder as a square pyramid is to a rectangular prism. Thank you guys for watching. Do not memorize the formulas, but understand how we derived all of these. And I'll be back to talk about spheres.